Good day everyone, my name is Graphics. In this video, we want to solve a problem involving a DC circuit. And the question goes like this. It says, a voltage source supplying 60 volts DC to the circuit of 4 resistors with R1 equals to R2 equals to R3 equals to R4 equals to 20 ohms. Using Kirchoff method, determine the Kirchoff equation, the branch current flowing through each resistor, the voltage drop across the resistor, power dissipated by each resistor, the total power delivered by the source. Now, the first thing we have to do is that if you look at your circuits, it says we have a source which is 60 volts, right? And we have 4 resistors, which is resistor 1, R1, R2, R3, and R4. And each of these resistors are equal and they have a resistance of 20 ohms, right? Now, we're not told that we should look for the branch current. So the first thing we have to do, we need to look for the Kirchoff equations, right? As suggested by the question. Now, if you look at it very well, let's take each of these points to be A, B, C, D, E, F, G, and H, right? And we'll take each of the mesh to be I1, I2, and I3. Now we take clockwise direction of each of this mesh. So we say I1 is going in this direction, and I2 is going in this direction, and I3 is going in this direction, right? Now, due to the fact that I1 and I2 are sharing a branch, right? So we say that the current flowing through this branch here is I1 minus I2, right? So this other branch here, due to the fact that it is separating the mesh of I2 and that of I3, we say the current flowing through this I3 here, this resistor 3, is given to be what? I2 minus I3. Now, because this is mesh I1, the current that will be flowing at the top here will be what? Will be I1. And the one flowing here will be what? I2. And the one flowing here will be what? I3. This is what we have here. Now, looking at this closely, we want to consider each of this mesh. Now, let's consider mesh ABGHA. And this is what we have when I consider it. I'm bringing it out from the entire loop there. And this is what we have here, right? We'll be having the 60 volts source. We'll be having the resistor R1. And we'll be having the current flowing to the resistor I1 minus I2. And we have the current flowing at this point here, which is what? I1. Then this is my I1 moving in clockwise direction. Now, since I1 moves in clockwise direction, we know very well that current flows from a lower potential to higher potential, so making our voltage source there to be what? A positive 60, due to the fact that the current is flowing from the negative to the positive, so we're having a positive 60. And in some cases, you can decide that the current flowing from lower potential to higher potential is negative. You still get the same value at the end of the day, but you have to be very careful. Now I'm taking my current here to be flowing from a lower potential to higher potential to be what? 60. Now, when current flows through a resistor, right? The current flowing through a resistor in this branch BG is given to be I1 minus I2. And when current flowing through a resistor, there will be a voltage drop. So we'll say minus 20 into bracket I1 minus what? I2. That is my resistance I have there, right? Equals to what? 0. Due to the fact that it is going the same direction as my own direction, that is why I'm having a negative value as my what? My resistance here. Now, one thing you need to understand is if I make my 60 negative, automatically I'm reversing the case. Then my resistor here will be what? Positive. So you have to be very careful. Now, equals to what? Equals to 0. Now, if I expand, I'll be having 60 minus 20 times I1 will give us 20 I1 plus 20 times I2. Because we multiply minus 20 I2 times minus I2 give us plus 20 I2 equals to what? 0. Now, if I take the minus 20 I1 plus 20 I2 to the other side, the negative 20 I1 will become positive 20 I1, and the positive 20 I2 become negative 20 I2 because they are moving to the other side, and I'm leaving 60 in the left hand side there, while the rest are moving to the right hand side. So this is what we have here. Now, if you discover something here that 20 can go in everything you have here in this equation. So 20 in 20 I1 is what? 1 I1. So we essentially are saying I1 minus 20 in 20 I2 is given as what? 1 I2, which is something as well saying I2 equals to 60 divided by 20. That will give us 3. So we're having what? 3 here. Is that okay now? I'll term that my equation 1. So this is the first mesh equation we have here. Now we'll move forward. We'll consider mesh BCFGB. So I'm bringing it out. This is what we have here. Start taking. So in doing that, I'll be having the R1, R2, and R3, right? Having a resistance of 20, 20, 20, like we said earlier. And the current flowing through R2 in that branch is given as I1 minus I2 as shown in the loop above, while the one flowing through the R3 is I1 minus I3. Then we're taking this my I2, we're going in a clockwise direction, right? So I'll be starting from what? From point B here. Now we're moving in clockwise direction, the same direction as the current. That is why we'll be having a negative value. So we'll be having negative. The current times the voltage will be negative 20 I2. Now still flowing to the same direction here as the direction of my current. So it will be negative 20 times negative 20 into bracket I1 minus what? I3, right? Now if you look at this, I'm now moving from what? From G to B here, right? So I'm going against the direction of the current, right? They are opposing each other. So we'll now make it to be what? Positive. So I'll be having 20 into bracket I1 minus what? I2. Is that okay now? So this is what we have here equals to what? 0. Now if I expand, I'll be having minus 20 I2 minus 20 times I2 give you minus 20 I2 plus 20 minus 20 times minus I3 give you plus 20 I3 plus 20 times I1 will give you 20 I1 minus, because you multiply, plus 20 times minus I2 give you minus 20 I2 equals to what? 0. Now if you collect like terms, discover that we only have one value that is of I1, that is 20 I1. I bring it out. Then you discover that I2, we have minus 20 I2 in 3 places. So if you add them together, we're having minus 60 I2. Now plus, we left with the 20 I3 equals to what? 0. Now you discover that 20 can go in the entire value here. So to make the work easier, I divide through by 20. So I'll be having 20 into I1 give you 1 I1, which is saying I1. 20 and 60 I2 give you 3 I2 plus 20 and 20 give you just 1 I3, and that's what? Just I3 equals to 0. That will be my equation 2. Now if you look, we'll consider the third mesh, which is mesh 3CDEFC. This is what I have here. Now if I do the same thing, I discover that I'm moving in a clockwise direction, right? I will start from point C. So we are moving in the same direction. I3 is moving. Remember, I3 is not splitting. It is just moving from C to D to E to F. So it is just one current flowing, right? So now that's why we're not having any subtraction of current there. So since the current I3 is moving, it's in series with the resistor there. So we'll just say that with minus 20 I3 because it is flowing in the direction of the current, right? So we're moving in this direction. Now we're moving in negative. So 20 I3 minus 20 I3 plus. Now I am moving up, right? I'm now opposing the direction of the current. So that make it be what? Positive. So positive 20 into bracket I2 minus what? I3 equals to 0. Now if I expand, I'll be having minus 20 I3 plus 20 I2. When you multiply 20 times I2 give 20 I2. 20 times minus I2 give you minus 20 I3 equals to what? 0. You need to understand the reason I'm having 0 in the second and third mesh because there's no voltage source there. You should have that in mind. Now, if you discover that 20 can go in the entire value we have here, once you add collect like terms, discover that the 20 I2 and minus 20 I3 will give us minus 40 I3. We've collected like terms and you discover 20 can go in each of those values there. So 20 in 20 I2 give you I2 remaining. 20 in 40 I2 give you 2 I3 remaining equals to what? 0. That is what? My equation 3. So combining the equations 1, 2, and 3, we'll be having I1 minus I2 is equals to 3, I1 minus 3 I2 plus I3 is equals to 0, I2 minus 2 I3 is equals to 0. So these are the mesh equation as suggested by the question. Now if you move forward, you can decide to use whatever method you want to use. You can decide to use your elimination method. You can decide to use your substitution method. You can decide to use your Cramer rule. You can decide to use your Saros rule, any method of your choice in order to acquire the value of the current I1, I2, and what? I3. Because the question says us to find the branch current flowing through each resistor. So that's what we need to get the mesh current I1, I2, and I3, and the branch current and so on. So I'll need to write this equation in argument form, and I'll be having the quotient of I1 in equation 1 is 1, the quotient of I1 in equation 2 is 1, the quotient of I1 in equation 3 is 0 because there's no I1 there. Now in the next one, the quotient of I2 in equation 1 is minus 1, quotient of I2 in equation 2 is minus 3, quotient of I2 in equation 3 is 1. Now for the third one, we have the quotient of I3 in equation 1 is 0 because there's no I3 there. Quotient of I3 in equation 2 is 1. Quotient of I3 in equation 3 is minus 2. So this is what we have. Then we have I1, I2, and I3 equals to the value of the constant out there, which is 3, 0, 0. This is what we have here. So the first column is 1 for I1, second column is for I2, and the third column is for what? I3. And we have written this in matrix form, right? Because we want to use Cramer's rule in solving this question here. So applying Cramer's rule. So the first step you do in applying Cramer's rule, which we call the determinant method, is to represent this equation here with a value. So I'll be using delta to represent it. So I'll say let delta be equals to everything we have here. I1, 1, 0, minus 1, minus 3, 1, 0, 1, minus 2. So this is what we have here. Now we're going to look for the determinant of what? Of delta. So determinant of delta will now be equals to, now I'm going to take the first column. So the first column is positive, second column negative, and the third column is what? Positive. So that's what will have the value up there. So when I take the first column and the first row, right, I'll be left with what? Minus 3, 1, 1, and minus 2. That's what we have there, right? So if I take that out, I bring it out. So where they meet, the row and the column meet is 1. So 1 will be outside, while the remaining one will be inside, just like you can see here. Now the next one is, if I take the second column and the first row, because we leave the row constant. So the next in the second column. So where did they intersect? They intersect at minus 1, but there's a minus 1 on it. So minus times minus is plus, so I'll put the plus 1 out there. Now I'll be having what is remaining? 1, 0, 1, minus 2. This is what we have here. Then for the third column, we have 0 plus 0. Then what is remaining? We have 1, 0, 3, and 1. That is what we're having there. Now, by using cross multiplication, right, we'll be having my delta, determinant of delta will now be equals to, we have 1 into bracket, you open your bracket, minus 3 times minus 2 will give us 6 minus 1, right? You're discovering that in each of those brackets, there's a minus in between naturally. So we're having what? Minus 1, because 1 times 1 is what? 1. Now the next one is, I have plus, open the bracket, the minus, natural minus in between naturally. So we are cross multiply, minus 2 times 1 will give us minus 2. Then 0 times 1 will give us what? 0. So the next one again, I open my bracket, put 0 outside. I'll be having 1 times 1 is 1. Then 0 times minus 3 will give us what? 0. This is what we have here. So this will now be equals to 1, open bracket, 6 minus 1 is 5, plus 1, open bracket, minus 2 minus 0 is minus 2, plus 0, open bracket, 1. So when you do the needful, 1 times 5 is 5, minus 1 times 5 is 5, 2, 1 times minus 2 is minus 2 plus 5, so that is 5 minus 2, plus 0 times 1 is what? 0. By the time you do the needful, 5 minus 2 is 3, 3 plus 0 is 3. So my determinant of delta here is what? Is 3, right? So the next thing we'll be having here will be, we'll see that let delta I1, now I'm using subscript I1 here as my value. So I'll select delta I1 be equals to, now I'm going to remove the entire value from the first mesh here, the first column here, and replace it by what I have outside, that is 300. So I'm going to remove 110, that is the one belonging to I1, I'll replace it by what I have outside the equal sign, which is 300. So if I replace that, everything remains intact. So I'll be having 300 minus 1 minus 3, 1, 0, 1, minus 2. So I will repeat the same scenario, right? I will take the first row, I'll take the first column, right? I will leave for 3 outside, then the remaining one will be inside, what we'll be having inside. You can see that. So taking that will be 3, what we're having minus 3, 1, 1 minus 2, plus, how am I using plus? Because the second column here has a negative on top. So minus times minus will give you plus, we're having plus 1. So if you take the first column and the first row, which is constant, I'll be having 0, 0, 1, minus 2. Plus, I take the third row, the third column, and they have one thing in common, which is 0. I put the 0 outside. So what will be left inside? It will be 0, 0, minus 3, 1. And this is what we have here. So write it out, open the bracket, 3 open bracket, plus 1 open another bracket, plus 0 open another bracket. Why am I doing that? So in between each of them, we have minus, minus, minus naturally there. So if I cross multiply, minus 2 times minus 3 will give us 6. Then 1 times 1 will give us what? 1. Minus 2 times 0 will give us 0. 0 times 1 will give us what? 0. 1 times 0 is 0. 0 times minus 3 is 0. So at the end of the day, we'll now have 3 into bracket, 6 minus 1 is 5, plus 1 times 0 minus 0 is 0 times 1 is 0. 0 minus 0 times 0 is what? Is 0. So we're left with what? 15. Now that means my I1 now will now be equals to determinant of delta 1 all over determinant of delta I1 all over determinant of delta, and that will be equals to what? 15 all over 3. So we have I1 to be what? 5 ampere. So it's 5A we have there. Now similarly, you say let delta I2 be equals to, now since I'm talking about I2 now, I'll move the second column, replace it with what? The value I have outside my equal sign, right? So it will now be from the initial question that we have, it will now be 110. So the second column, I'll remove it. Instead of having -1 -3 1, I'll now put 300. That is the value outside the equal sign. So we'll now have the remaining one intact, 0 1 -2. So I'll do the same thing. I'll take the first, this is plus minus plus. I'll take, looking for determinant of I2. So I'll take the first column, the first row, which is constant, and the first column, what they have in common is 1, right? So I'll be having 0 0 1 -2 remaining. Then the second column, I have minus on top, so it will now be -3, right? So what I have remaining, 1 0 1 -2. Plus the third column, what I have in common between the row and the column is 0, into bracket 1 0 0 0. Now with that, I will take my 1, open the bracket, take my -3, open another bracket, take my 0, open another bracket. So we're having negative in between naturally. So -2 times 0 will give us 0, 0 times 1 will give us 0. Put another negative again, we have -2 times 1 here, give us -2, 0 times 1 is 0. Then we have 0 times 1 is 0, 0 times 0 is 0. So in long run, 0 minus 0 is 0, 0 times anything is what? Is 0. Minus 3 into bracket, -2 times, -2 minus 0 is -2. So plus 0 times anything is what? Is 0. So at the long run, we'll now have -3 times -2 will give us what? 6. So my I2 will now be equals to delta I, determinant of delta I2 all over what? Determinant of delta. So it will now be 6/3, and that will give us what? 2 ampere. So the current, the I2 current is what? Is 2 ampere. Similarly, from the main equation, we'll go back again. We'll now say let I3, right? I3 here now mean that I'm going to remove the value of I3 in the third, that is the third column, replace it with what? What is outside the equal sign, which is 300, right? So in that case, I will now be left with 110 minus 1 minus 3 1, then it will now be 300. So this is what I will be left with. So I will now do the same thing again. Determinant of I3 will now be equals to, I have take the first row, which is constant. Don't forget this is plus minus plus. So take the first column and the first row. I'll be having 1, what they have in common. So what will be left will now be -3 1 0 0, plus I'll take the second column. So what they have in common is -1. So -1 times the minus up, they'll give you +1. So I'll be left with 1 0 0 0. Then if I take the third column, I'll be left with what? +3, what they have in common, where the row and the column meet is 3. So open the bracket, this I will now have what is remaining, 1 0 minus 3 1. So I'll now take the 1, open the bracket, plus the other one, open another bracket, plus 3, open another bracket. Now negative in between. So I'll start, 0 times -3 is 0, 1 times 0 is 0. Then we have 0 times 1 is 0, 0 times 0 is 0. Then we have 1 times 1 is 1, minus 0 times -3 is 0. So the long run, we'll now have 0 plus 0 plus 3 times -1 is what? 3 times 1 is what? Is 3. So having that to be 3. So I'll now say that my I3 will now be equal to the determinant of delta I3 all over determinant, and that will give us 3 all over 3, and we're having 1A, right? 1 ampere. So we'll now say that the question says to look for the current through each resistor. Am I correct? Branch current flowing through each resistor. So the current flowing through R1 is, from the equation we have, is I1 minus what? I2, right? And I1 is 5, I2 is 2. So 5 minus 2 is 3 ampere. So the current flowing through R1 is 3. The current flowing through R3 is equals to I2 minus, or let's say the current flowing through R2 is equals to what? 2 ampere, right? And the current flowing through R3 it gives us to what? I2 minus I3, which is 2 minus 1, that is 1 ampere. And the current flowing through R4, the way we will detect that, we will apply junction rule at that node there, but we'll talk about the node C, right? So when I say the current coming in is what? I2 is coming into C, then it's because of the current leaving. That is I4 is leaving, right? So since I2 is coming into C, I2 is negative, I'll put negative I2. Since I4 is leaving, I'll put positive I4, right? I'll put positive I4 plus, I'll put positive I4. Then since I2 minus I3 is leaving 2, I'm going to put positive I2 minus I3. Is that okay now? So in the long run now, we'll now be having my I2, negative I2 is 2. From the questions we have negative 2, right? My I4 is leaving, so positive I4 plus I2 is 2, then minus I3 is what? 1 equals to 0. So discover that plus minus I2 minus 2 plus 2 will cancel out. So we're left with I4 minus 1. So when 1 comes to the other side, my I4 will now be equals to what? 1 ampere, right? So depending on what you want to do, you can decide that your current coming in is positive and the current going out is negative. Any one you do, you get the same value. So my I4 is what? Is 1 ampere. So the question now says look for the voltage drop in each resistor. Now for resistor 1, we say that V1 is equals to what? I1 R1, right? So my V1 now will not give me I1 is giving us 3 ampere, and that is what? That is the current flowing through the R1 resistor, and that is 20. So 3 times 20, that is my R1, that will give us 60 volts. So the voltage drop across R1 resistor is 60 volts. For R2, so V2 is equals to I2 R2. So the current flowing through R2 ohms here, as you can see, is 2, and that is I2 multiplied by the by the resistance, which is 20 of resistor 2, which is 20, equals to what? 40 volts. So for R3, V3 is equals to I3 R3, and that will give us what? I3 is given to be 1 multiplied by 20, and that will give us what? 20 volts. So for R4, we have V4 equals to what? I4 R4, and that will give us what? 1 times 20, because I4 is 1, and that will give us what? Another 20 volts. So this is what we have. So the total voltage drop here, so that's what we have here. So we'll move to power dissipated on each resistor as suggested by the question, and that will be across resistor 1, so P1 is equals to I1 V1. So I1 means the current flowing through the R1 ohm. So the current flowing through the R1 ohm is 3. So it will be what? 3 times 60, right? So 3 times 60 will be giving us what? 100 and what? 180 watts, right? Because that's the current flowing through the R1 ohms. So the next one is P2 will now give you I2 V2. So the current flowing through the R2 ohms have a voltage drop of what? V2, which is given as 40, right? So V2 is 40, so I2 will now give us what? 2 times 40, and that give us 80 watts. So P3 will give us the same thing, I3 V3. So the current flowing through the R3 ohm, so the power is I3, and the voltage drop there is given to be 20 volts. So 1 times 20 is 20 watts. Same as P4 equals to I4 V4. So the current flowing through the R4 resistor is I4, and the voltage drop of the R4 resistor is 20, and that will give us what? 1 times that is 20 watts. So we will now say that so we calculated for what? The power dissipated in each resistor, right? So the next thing is we calculate for the total power delivered by the source, right? So we're going to add all of them. So the first one, which is 180, so 180 plus 20, which is 200, plus that 20, which is that is plus another 20, It is 220 plus 80, that would be what, 300, right? So this is what I mean. You add that will be 300, right? So this is what we have, the total wattage in this circuit. So if you found this video helpful, please don't forget to subscribe, like, comment, and also don't forget to share the video. Thanks for watching.